Okay, so we need to make a OpenGL polyfills namespace for specifically OpenGL polyfills. Well, I mean that makes sense, right? The way we're writing our shader code, we're writing C99 code that can also compile as GLSL by doing kind of like really tricky, define, hackish nonsense. But it's so far it's working out pretty well for us. So what we want to do is figure out, well, where does it go? Where does it go in here? So this thing here, I think it actually needs access to some, we're emulating texel fetches, and the texture memory also is all stored in here on the CPU side, so we actually kind of need this. Now the tau thing, do we need access to tau depot for any reason? Tau depot would be used. There could be times when we're going to use these polyfills where maybe we need access to those tau functions. Now the other thing is, well, what if we want to make some type of default shader that just can inspect tau? We could do that. However, right now for that system, we're just using some type of default shader, right? So if we look at, hold on. So basically, I think that at first I was thinking it would go here, right? It would go, first I was thinking, hey, we need to put this OpenGL polyfills after OpenGL bindings and OpenGL constants. Then I'm like, wait, but it needs access to the CPU uniform. So it needs access to this. It absolutely needs. So the thing that this needs access to, this right here, it also needs access to pixname. Like, without a doubt, it absolutely needs to come after this stuff. The other things are kind of like up for interpretation or up for guesses. So here, what we could do here is we could save this as first of all, let's just stub this in, right? So this is going to be called now we're just going to call it Polyogl, right? And so it shares part of its name with this thing here, right? Polyogl. And Polyogl is polyfills for OpenGL. Now, I don't know. I think it's just, well, actually, no. It's going to have functions and data. So let's save this as polyogl.f. So we got a functions file and a data file for Polyogl. And we can constrain or add a little bit of protection here, right? So we have a very strict order in which everything is included, but that doesn't mean that that's the exact dependency order, right? Things don't have to be in this order, but because of the, right, in source code, a lot of instructions don't have to be in the order you write them in, but you're forced to write a linear narrative. And same thing here. We're being forced to write a linear narrative, so there is some wiggle room as to the exact ordering of these, but we have to pick something that's a decent solution or a close to optimal solution. Also, linear narrative. So, if, so there's this AMD guy that did a talk with Lex Friedman, and he talked about instructions on a processor just being executed out of order and all sorts of craziness, like branch prediction and whatnot. And he talked about the idea of a linear narrative. So what I want to do here is I want to just, well, first of all, I want to go to my dashboard, make sure no one's trying to talk to me. I don't think so, because I don't really get many viewers, especially when I'm programming at these just odd hours. But I want to make sure no one's trying to talk to me. So let's open up the dashboard. Yeah, nobody's talking to me. That's fine. And let's look at Lex Friedman AMD. So there's this guy who does like coding for AMD, Moore's Law microprocessors. So yes, I think it was this guy right here. And somewhere he talks about a linear narrative. Now, I don't know if I can find where.
The following is a conversation with Jim Keller, legendary microprocessor engineer.
So let's try to see it.
So branches happen a lot. So imagine you have a decision to make every 6 instructions, which is about the average, right? But you want to fetch 500 instructions, figure out the graph, and execute them all in parallel. That means you have, let's say, if you fetch 600 instructions and it's every 6, you have to predict 99 out of 100 branches correctly for that window to be effective.
Okay, so parallelism, you can't parallelize branches, or you can.
No,
so
you can.
What does predict a
them.
branch mean? Well, what does predict?
So imagine you do a computation over and over. You're in a loop.
Yep.
The found parallelism in the narrative, right? And the other is you can just say it's parallel because you told me it was.
So found parallelism where the narrative is sequential, but you
serial narrative to execute. Fetch a lot of instructions and find all the parallelism. Now there's a second kind of computer, which we call GPUs today, and I call it the difference. There's found parallelism, like you have a program with a lot of dependent instructions. You fetch a bunch, and then you go figure out the dependency graph, and you issue instructions out of order. That's because you have one serial narrative to execute, which in fact can be done out of order.
Did you call it a narrative?
Yeah.
Wow.
So humans think in serial narrative.
Okay, so it's not a linear narrative, it's actually, he called it a serial narrative, which basically probably means the same thing, right?
You have one serial narrative to execute, which in fact can be done out of order.
Did you call it a narrative?
Yeah.
Wow.
So humans think in serial narrative. So read a book, right?
Okay, so yeah, serial narrative is what he called it. So I need to go find where I put that. In my shortcuts, and I'm working on my shortcuts here, so I'm gonna put that in here. Every time I have something interesting to mention, like I actually want to have the source for that, right? So linear narrative. So linear narrative is actually what I wanted. But I remembered it as serial narrative. Serial narrative, right? Serial versus linear, kind of the same kind of thing. Serial story, serial story, serial story, or no. Serial story, right? So I actually don't mean, so the source for this is this guy, and this is, what was this person's name?
You have one serial narrative.
Alright, so that's the source, linear narrative. But it's not linear narrative, it's serial narrative, right? So serial narrative is the source for this. And we can paste this here, so both times we need, let's just call this Jim Keller Lex. Alright, Jim Keller on Lex Friedman. Make this shortcut number 1, shortcut number 2. In Jim Keller Lex, we could do, pick Jim Keller Lex URL or Jim Keller Lex vid, right? So we have 2 things that we could do for this. So let's take this URL and just say, you know, Jim Keller Lex URL, right? So this is the exact quote for that thing. And then we might want to archive this as well, right? So we'll want to save this. YouTube doesn't like you downloading their stuff, but technically I'm not downloading YouTube stuff as far as I'm concerned. I am downloading Lex Friedman's stuff, so and I don't think he has a problem with me archiving his stuff. So unfortunately, Torch browser no longer works for downloading videos off of YouTube for some reason. So so we can do YT downloader. But we can keep this off screen to say plausible deniability. For all intents and purposes, I got this video directly from Lex Friedman, not from YouTube. For all intents and purposes, right? For all intents and purposes, I am getting this directly from Lex Friedman. Anyway, so let's take this. And I may have... I know I watched this before, so I probably already have it, but, you know, having more than one spot for it. So it's going to be in my educational folder. We're going to put it in vid, YouTube, and then the 2021 folder for YouTube. And 2021, we've decided to kind of index everything in order because it makes it easier to make playlists. So this is video number 9. And it's Jim Keller. So Jim Keller Lex. So JKL. And we'll just take that, and that'll be for this, right? Okay. So now that we have that, that little kind of distraction, but I had wanted to know where that was from for quite a few months, and it's once again it has come up again as I kind of wander and talk randomly, so I thought we would get it. So, yeah, so we have this linear narrative of how, or this serial narrative of how all the libraries need to be included, but there is wiggle room as far as the exact ordering you could use, right? So, we want to use some type of ordering that is proper and sensible, and we could further restrict the ordering by using some defines. So, for example, we could say this libchan order here is going to have an order, and we could say that if so we're just going to do this, right? So if we include so this is kind of long. Now, can we do a directive with a macro inside of it? And I don't know if that's true. Can we do a directive with a macro inside? Because this is getting long. Can we actually get away with that? So I actually want to know that. So let's open up a new file and kind of test this out. So let's say int main void pedantic. Make a little test file here. And let's just not even worry about what's in here. Let's just keep the printf. Let's remove the malloc and whatever the heck. Ooh, I deleted everything except for that. Let's just take this and say, you know, define 1 as 1, and then define 2 as 2. And we want like a if not 1 greater than, or if not 2 greater than 1, right? This is kind of what we want to do. But the question is, will the preprocessor understand that, right? Will the preprocessor understand this, or by nesting these macros inside of other macros, will that just not work? Well, well, the other thing is, this is kind of like, so this is what we're doing. We have some extra indirection. Earlier, we found that, whatever. Earlier we found that macros, when they're, when you're going through the preprocessor, it actually is not a one-time replacement. It'll actually, like, lock up the tree of associations. But we want to make sure that that kind of same thing can happen here. So if we want to do this inside of logic here, but it's like, oh boy, that's a lot of stuff. We want to take some time to shorten that up, right? So we want to take, we want to define 1 and 2 here, right? So we want to define them here to shorten up this phrase, right? Then this phrase is just a comparison of, like, 2, like, macros that are have really large names, right? And we want to shorten that up and see if we can get this working, right? So if not, and if, and then let's put an else in here. Else, and then let's do printf in order, right? Printf in order, and then the other one we can do not in order or out of order, right? And we're just trying to see if this kind of stuff works as we think it's going to work, right? So, so CXX folder. The idea here is to kind of test our understanding. Define shorthand compare. Or actually, if compare macro short, right? If compare macro short, let's just call it compare macro short for CMS, or let's just do, no, if compare macro short. Let's use ICMS just because those are the letters of each thing in there. So ICMS.C11. Then we'll do HKMF C11 mini. So make a little kind of build file here. And this will be ICMS, right? For the file that we want to compile, and then all this nonsense, then that's fine. And we'll call this ICMS.sh, right? So now we just want to open this up and see if this actually works properly, or if we get some type of weirdness, right? Begin, it's in order. Okay, so that's what we expected. So now, if we swap these around, right? So if we swap around these numbers, right? So if we go 1 and 2, we're going to expect, sorry, did I do 1 and 2? 2 and 1. If we do 2 and 1, we're going to expect it to say that it's out of order, right? So let's try that. Okay, cool. So out of order. So that seems to work how I was expecting it to. So let's put that back. And let's just do ICMS demo, ICMS research, libchan order enforce, libchan order helper. This is like some type of demo for that, so I'm just making a shortcut for that. And so now that we know that kind of works that way, we can say define, and we can say We could say polyogl ord, something like that. Or order polyogl, ord polyogl, right? General to specific, so that might actually make more sense. And we could take all these different macros. So ord CPU info, define ord pixname. And is there anything else that we absolutely are saying, we absolutely certainly want this stuff, right? And I'm not sure of anything else, but I know strictly speaking that these things absolutely need to be declared. So we're going to take these macros and just be like paste, paste, and paste. And, right, so these are just the libchan orders. And we could change this to like libord, right? Or libcord. Right, libchan order, right? Now that kind of makes things kind of hard to see, this part here, though, when you do that. So we could do this, like, lowercase, libcord, so libchan order, and then these things, right? So these are still macros. They're defined locally, so we don't have to worry too much about making sure that the way we name them is consistent, right? We can break the naming convention and name these very oddly because these are just local macros, if that makes sense. So we know that this needs to be oh. Alright, so we can say this and say and then same thing here. So we can say that the order of polyogl needs to come after CPU info. It also needs to come after pixname. So we could call this libord, libcord, libchan order. Alright, and then right here we can just do a undef, and then we can undef all this stuff, right? So we can undef all these things, and oh, so here we can just say error, and we can just say that we can just say polyogl uses CPU info, thus must come after. So we can create a little error thing here. A little error macro. And then over here, same thing here. Polyogl uses pixname. And if we really want to, we could line that up nicely. Let's just call it ord. Right, we're only going to use it local, and if we call it ord, I think everything will line up a little bit nicer. I know that's kind of stupid to be like, well, let's just change it because of how the text lines up, but that's kind of what I do. So let's change this a little bit, because I think that the error messages will line up a little bit nicer if we make this a little bit more concise as well. So we got this, and we got this, right? So we can take this. Yeah, and so we can backspace to here. If not this. We're going to change it to use polyogl use CPU info. Thus must come after. Right, so... Right, and we just kind of named it like that so that we can see polyogl right here. And then we can see pix name right here. We can see them all kind of like lined up nicely, and I like that, right? So it's purely kind of a cosmetic choice to feed my OCD kind of desires here. But I like it. So now what we can do is we can... Gotta take a break. I'll be right back. Ooh, that doesn't look good. Am I dropping frame? Oh, I'm dropping 57% of my frames. Great. And it's always the weeks when they have the kids over that I start dropping frames like crazy. Great. So my stream's unwatchable. That's great. Okay, well, let's just stop the break now because no one's going to be watching. Or actually, no, let's keep it going. So when people are scrubbing through here, they can actually find what they're looking for. But, yeah, just, infuriating. This stream 114, isn't it? OGL. Really, this is OpenGL polyfill, so I should change the name. And are we still dropping? Yeah, we're just dropping frames like crazy.
The following is a conversation with Jim Keller, legendary microprocessor engineer in autonomy.
Although we
Okay, so I got that. Yeah, I am. This irks me. Anyways, so we're going to take this libchant order thing. And this is actually quite a lot of code where it's a lot of annoying stuff where we don't really care too much about seeing this. I think it's just going to distract us when we open up this file. So I think we're going to say include polyogl, include /polyogl libchan order we're just going to give it a ridiculously long name because we're not going to have this open very much, and it's also a non-standard extension, right? So standard extensions are either F or D for function file or data file. If it's anything besides that, then it's not a standard file name. And we just want to take this nonsense here and put it in here so that we can just ignore it, right? So that we don't have to look at it anymore, right? And we can make a note of this, of why this is like it is. So we can make a note of what we're doing here, right? So why does this file have the structure that it has, and why are we enforcing the things that we're enforcing, right? So I'm gonna take the video ID, and we are on, hold on, let's move this over here so I can see. The video ID we're on is 114, so 0114, and the time is 38 minutes and 32 seconds. Polyogl uses pixname to emulate texel fetches. Polyogl uses CPU nifo to emulate right. So this is the reason why we have the constraints we have here, right? This is why we need to know about polyogl and CPU uniforms, etc., right? So it almost seems to me like we might want to just get rid of the thing that says ord, right? I think that ord is just kind of redundant, and I think we would be fine if we just did this, right? If we just did it like this, and then we can just say, oh, polyogl, right? And then we reference it like that. I think that might actually make more sense. Because then we don't have to... It makes it terser, and then also, you know, when we're reading this, we can click these, and then we still see it kind of lining up. So CPU, and I already see that I spelled something wrong, so CPU nifo, CPU info, yeah, so CPU info like this, and this is already wrong, so it's good that I kind of caught this. But if we see how I do it here, it's CPU unifo, right? So uniform info. So we want to take the incorrect spelling, so CPU info, it's not actually CPU info, and this has been a bane of my existence for a while, where I named this, I gave it this shorthand acronym, but it's so easy for me to get wrong, and it annoys me, but oh well. So we're going to save this, and we're going to save it as libchan order enforcer. So we're going to go over here, and we're just going to save it, and we're just going to call it polyogl, so polyogl.libchan_order_, right? Which is a ridiculously long, annoying name, right? Now, I see that, yeah, it's kind of annoying. Also, when I'm trying to read this file name, I'm having trouble reading it. So let's try to rename it to something else. Let's try, like, we can be as weird as we want. So I'm actually going to give it 3 underscores. 1, 2, 3. Polyogl libchan order enforcer, like that, so that I can actually kind of read it. Now, obviously, it's kind of hard to look at that and be like, how many underscores are there? I don't care. In this case, it doesn't really matter. It's not something that is going to be used that much to where that is going to make me worry about it, right? So, polyogl libchan order enforcer. So this is just, these triple underscores is just a way to give us a visual space between here and here when we're reading it. And, yeah, so we just want to include it here, and then we also want to include it here, right? So we just want this thing so that we include the data file and the function file and the data file. It has some extra ordering constraints, so that if we put this thing, if we included this right here, it would crash, because of these extra ordering constraints that are attached to the file, right? That's just so that we know we need to put it somewhere, and we can put it anywhere here, and it would be fine. But it needs to be after these things that are highlighted in blue. So the next thing is, what about pixel savers, pixel backup? Like, where do we want to put it? So it's like, where do we want to put this in a way where it kind of like makes sense? Now, do we think we're ever going to need access to tau? Now, if we try to put it after the tau stuff, then we're not going to be able to make a detailed like tau shader later that kind of looks at the actual memory. So I think that we actually want to put it here. I think we want it here. And the reason I think we want it here is because I think we want to leave I think we want to, even though we're not planning on it, I think we want to leave open the possibility of writing shaders that will display the information in tau. And if we're going to do that, then well, it doesn't really mean that it has to be before this. Well, what we're saying is that this is all of the tau systems, right? And so we want to have this before the tau systems, so that the tau systems, if they wanted to write their shader code, if they wanted shader code specific for the tau system, we could do that, right? Like, for instance, the PAINT5D system is going to use these polyfills, so therefore if we want a shader for this tau system, for subsystem 0, then we would also want these polyfills over here. So I think that we'll put this here, and then we'll also edit this, right? So we'll say, let's include, let's just include all of these, right? Let's just say, actually, let's just do another block. Let's do another block here. And let's include, so these are 4 different things, right? So copy, and let's do this. Let's paste this. Ooh, hold on. I tried to do a copy and I screwed that up. So copy, not paste. And then we'll paste this down here. Right, so we have these. And, we want Polyogl to be less than these, right? So let's just do T1, T2, T3, T4. And then OGL, Polyogl, let's define this again. But let's call this Po for poly, whatever. And so if not, right? So we're just going to say that we have explicit ordering here, and we want to make sure that the library is also comes before. All right, so it's going to come after these, but we want it to come before tau-dirt, right? And then we can undef this over here. So just call this undef. And this is wrong here. This is an endif. I don't know why we have an endif like this. So well, if endif, this is undef, right? So we got this first chunk. So, right, we have a lot of crazy stuff we can do, right? And this could really clutter up the main file if we want to paste all this cruft into the main file. So the idea is that we can do this kind of here, and we can, you know, we can put these constraints here in this file, so that we don't clutter up the main like implementation kind of files, or the like we don't want this to distract from the logic of what we're doing, right? So we can take this, we could indent this a bit, and that doesn't quite quite work. Except we could move this over and then bam. And error. Reserve right to right. So the reason why we want this is we might want to write a GLSL shader for the tau system. The future. And right, so we got to think about what we might want to do, right? So there's this whole idea of Yagni, you aren't going to need it. But just because you aren't going to need something, you can keep in mind of things that you might need and make like slight adjustments to how you do things, right? So my analogy for that usually is, if you think you might want a pool in the middle of your yard, maybe when you build your shed, you put the shed in the corner of the yard so you have room to build your pool in the future if you decide to do so. So it's a very minimal effort up front for that thing that you think you might need, but it'll save you a lot of time in the future if you end up doing it. Okay, so we have this, and then also it should come before any shader-based system, right? So we also need to say, you know what, so similar to this, right? So we can take kind of this logic here, and we can paste it again, and we can say that, right, this is Polyogl, and I'm just gonna call it a B. B for bigger. Yeah, B for bigger. And we just want PAINT5D, and we want this. I can't call it subsystem 1 and subsystem 2 because these conceptually are actually part of the same subsystem. So that's why I can't number them like that. So this can be B1 and B2. And then PO has to be less than B1 and less than B2 as well. Or we could call it P for paint, right? So paint system. And we can just make a note of that, right? So, PAINT5D uses polyfills. Right, so, Polyogl must be included before PAINT5D systems. Because those systems reference Polyogl polyfills. So they're actually really polyfill structs and polyfill polyfill functions, if you really want to think about it. But let's not split hairs. It's just whatever. Alright, so we can make a note of when we put this in here, right? So we can get really kind of crazy with enforcing certain orders. And this is kind of this is the opposite of flexibility, right? Like, we're getting super crazy and saying, you know what? We want to have this exact order, and we're going to put all this ridiculous code in here to enforce this order, right? So it's going to make it a lot harder to reorder this in the future, but we're being very confident about these orders, right? Now we're not going to specify everything relative to everything else, but the things that we are certain about, we can nail down and make the code less susceptible to people unintentionally refactoring it the wrong way. So this thing here, where it's like Polyogl, I think that this, let's just call it, PO does look kind of like P0. Oh, actually, not in my code, not with my font. So if somebody looks at this and thinks it's a P0, well, that's their fault for not using a proper programming font. So yeah, define, undef, so a ridiculous amount of stuff, right? So like almost 100 lines of just ridiculous stuff. So we could make a note of what this is. Libchan defines an exact ordering of subsystems. However, there is wiggle room in how you can order. Because in order. This file makes sure that we enforce certain ordering constraints that do not have wiggle room. Yeah, I don't know if that's a good explanation. We could have an example. B and C depend on A. X, Y, Z. Y and Z depend on X. Right? So we could say this. Right? So we could say that if we have an ordering constraint like this, valid order, A, B, C, D, A, B, C, X, X, Y, Z. Right, so this is a valid order here. But also a valid order would be X, Y, Z, A, B, C, right? Because these dependencies are unrelated, right? But in the libchan, we have to do something, right? We have to do something like this. Let's just say 5.7. Yeah. So in the libchan, we have to give some type of strict ordering where over here we have to order it in some type of definite order, but that order is not like the only order it could be in and still be valid, right? So if B and C depend on A and Y and Z depend on X, then we could do A, B, C, X, Y, Z, or we could do X, Y, Z, A, B, C, and those would be valid orders, right? Or another valid order would be something like, so B and C depend on A, right? So, actually that's good enough of an explanation, right? To make sure the dependent care about right? So basically, if we try to shuffle these around to get, for whatever reason we want to shuffle around these libraries and include them in a different order, we can, but sometimes we have to understand what depends on what here in order to not make any big mistakes. So if we want to codify that and make that kind of a little bit harder to break, we can put in a file like this to enforce certain orders, right? So this is, if we want to think of a summary of what's going on, right? So the code is quite large. So if we want a summary of what's going on, so summary of code below is basically CPU NIFO, fix name, and then Polyogl, tau dirt, tau depot, tau type, tau sync, PAINT5D, P5D1OGL, Polyogl, so basically, the summary of all that code below is literally just this, right? Now it's very verbose way to say basically this, right? So we might want to just put this at the top, because I think that this summary helps explain, if it's the first time you've looked at the code, then you're going to want to see this. But every other time, the only thing we really want to see is this summary, right? Right? So, libchan relative orders libchan orders we care about for Polyogl, right? So these are libchan orders we care about for Polyogl. That's all this is, right? And maybe we don't want to call it summary of code below, because that is kind of obvious. Maybe we're getting a little bit too designy now. But yeah, so we can just say that. And that way when we're looking at this, we can just look at this, and we can look at this commentary and be like, oh, that makes sense, right? We can look at this commentary and go, oh, this is where it is. Here's these two things that it needs to come after. Here's the things it needs to come before, right? And that's going to make it a lot easier than looking at all this nonsense. Right? As long as this nonsense is coded correctly, and we're sure of it, then we can just trust this commentary, right? So we can see that, yeah, Polyogl needs to come after this, and needs to come after this, and are these named correctly, and we have the not operator, that looks good. We have tau systems, 1, 2, 3, and 4, and the polyogl needs to come before, less than, all of these things, and if it's not, then we're going to have a little error. And then same thing here, so instead of T's, we have P's, P1 and P2 for PAINT5D systems, and it needs to be less than these PAINT5D systems because the PAINT5D systems are also going to use these polyfills, right? So that all looks good to me for like a little include guard. It's not an include guard, it's like an include enforcer, right? And so now that we know kind of like what we're doing here, we know that this is the insertion point we want to use, right? So we thought about it, and it took us some time to figure out. Where exactly we wanted to put this. But now we've thought about it, and the OpenGL polyfills, this is where they go, which is a long way from where we initially thought, because initially we thought we would put it right after the GL bind and the GL constants, because that seemed kind of like the sensible thing. But as we thought about it a little bit harder, this actually makes sense, and we're going to really commit to that, right? Because we're going to like make this libchan order enforce, which really cement that decision, right? So now we can take this, and we're just going to paste, right? We're going to shift up everything, and then we're going to call this 32 now. And then this right here, we're going to say 32, and this is the part that sucks, right? The part that sucks right now is to stub these in. To stub in these files, right, we have to open up a lot of stuff, right? So let's get going. Let's do that. So let's open up let's open up libchan. So libchan, top and bottom, and then also f macros. So open up f macros as well, f macros, bot and top. And then also we want to open up the main file, and specifically the main functions file. So if we look at the order in libchan, this is definitely something that, if we look at, let's just tackle one of these at a time. So f macros is the first thing on my mind for what I want to. So right here, P5D OGL, we know that the order for this, if we look at libchan again, or this libchan, it's right after pixload, right? So let's find pixload. So here's pixload. So we're just going to go in here and say, you know, f macros, and we're going to say polyogl, polyfills OpenGL, and init none, right? We're expecting not to have to do any type of initialization behavior for this. Hashtag libchan. So now the question is this 21 correct for pixload? And if we go here and look at pixload, it is a 25 right now. So we got an issue on our hands here where the ordering is not correct in the comments. So we might want to take a look at that and start fixing that before we... Alright, it's a comment, so it doesn't matter as much in the comment, but we really should take a look at this and be like, okay, we shifted a whole bunch of things around, so that makes sense. The numbers would change. But how have they changed, right? Like, what are we missing? So if we look at GL bind, right, we're thinking everything got shifted over a bit. So GL bind is now a 15 somehow. So the first thing we can do is just go like this, right? We can do this, paste that. And then we can look at this and be like, okay, GL bind is 15, so right here. GL const is 16. CPU info is still 17. Graquad still 18. Graquad is 18. 19 is still our free spot. Fragbet is still 20. Pix name. Tau Depot. Where's Tau Depot? So polyogl is right here. So pixload might be 25 now. So pixload 25. And Tau derp. So pixload and then polyogl goes there, right? So pixload. So after pixload, we got polyogl, right? So polyogl init none. And polyogl is 26. And then we can just, you know, put the rest in here, and I think we'll be okay, right? 26, 27, 28, 29, 30, 31, 32. Yeah, so if we do that... Right? And so we know that we can kind of keep on doing that. So GL bind init. So the only thing we're missing is this Polyogl, right? So, and that comes after, oh, we just stubbed that in, so we should be able to just take these numbers here. We should be able to take these numbers here from the AAC 2020 stuff, and in the F macros, you should be able to go, bam, put that in there, right? And now all these numbers should make sense. We can spot check this really quick and look at tau sync init none. Is tau sync 30? Tau sync is 30. How about free? Is the free spot still 19? Free spot still 19? So that looks good. It looks like we got that in. And well, the reason why we have this F macros here is so that we don't have to wrap all of this in if-defs. If this is included, if this is included, we can just look at this as a big chunk of initializing all the systems, and I feel like that just makes the code a little bit easier to read. So we can get rid of this. And we can start looking at some of the other things. So let's look at libchan top. And let's actually move libchan top over here so we can reference the C11 file, right? So we know polyogl, we want it to be 26, right? Well, so right here we know we have 32 libraries now, so we can add this next thing as 32. Make sure that these two things match right here. And then we can continue on our way down. This is going to be a little bit less tedious than before, because before we made an insertion way at the beginning, and this insertion is closer to the end. And remember, we didn't do this intentionally. We didn't intentionally make it close to the end. We put it exactly where it belonged, right? So, not 29, we want to be at 26. So tau dirt. So tau dirt is going to be shifted down, right, because it comes after. So let's just copy pixload. I think that will make more sense. If we copy pixload, so if we copy pixload, which is 25, paste pixload, and then pixload we just rename all this to polyogl, right? And then we just start numbering, right? We just start numbering. We say, hey, this is 25. We're just going to add 1 to everything. 26, 27, 28, 26, 28. This is 29. This is going to be our 30. And then we got this huge thing is 31. And this next thing is 32. So now we can go down to the next section and do the same exact thing for the function files. So we know we want to find at pixload is 25, right? So we want to find pixload at 25. And there you are, pixload at 25. We can copy this. We can paste this. And we can change pixload to polyogl for OpenGL polyfills, right? So polyfills OpenGL. So the idea is that maybe we'll have polyfills Vulkan, polyfills OpenCL. The idea is that that's the reason for the naming convention. And now we're just going to increment this, right? So this is going to be 26. This is going to be 27. We're just going to keep on incrementing everything up once to kind of shift everything down, right? 29. And this is 30. This is 31. And this is 32. Okay, cool. So now that we have that kind of in place, we can close that. And we want to look at libchan bottom now. So libchan bottom. And we want to insert this new polyfills thing in the correct spot. So once again, we're going to look for pixload. So here's the pixload macros for checking the ordering. We're going to paste this here, and then we're going to replace this pixload here with polyogl. And then this also needs to be turned to polyogl, right? So we copied pixload, and we refactored it to polyogl here. And that's just making sure that, you know, if we have included polyogl, right, it's not equal to 0, then the order of this include polyogl must be equal to the library chain order, right? So it's just a little reinforcement to make absolutely sure that that is correct. Then down here, we will also want to look for pixload. And we're going to have to copy this, paste this, and shift everything down. So we're going to copy this, paste this. We're going to change Pixload to Polyogl. And then we know what we're going to do is we're going to take this 25, right? And we're going to merge it with this 25 right here, like that. Bam! And then we call this 32, and then everything's been shifted down correctly. So now the next part is we have Pixload right here, same deal. So we're going to duplicate this and call this Polyogl. And then we're going to shift this up, everything up. We're going to shift everything up and call this 32. Okay, cool. So now that we have that, we can close libchanbot. And we can look at F macros. So let's look at F macros top. And the thing I'm most concerned about is these like 27s and stuff. So graquad and so let's look at this. So Polyogl is here. And if we look at CPU info stuff, that is over here. So that hasn't been changed. Neither has graquad, because graquad is over here, so that's still 17 and 18. However, the tau depot things have to be incremented by 1. So this tau depot should be 28 now, and tau sync should be 30. Tau sync is 30, yes. So we're going to change this to 28. So 28 and 28, and this is 30 and 30. And the thing is that this is very... This is kind of very rigid, but the idea is we want to keep a very rigid project structure to make sure we haven't screwed anything up. Okay, so now that we have that in place, we're going to go down to our init none function. So this is our section of init nones, and we're going to say, you know, we're pretty confident that these lists are correct, that these lists are correct. So let's have some faith in our ability. Hey, so I see somebody kind of showed up here. Here are my... I don't know... I don't actually see who's in the room. So if someone's viewing, I can't actually tell who you are because I don't really know how to use Twitch. But those are my technical demos. You can check them out, and those are all the little pieces that are going into this engine design. They're all the proofs of concepts. I'm working on a fractal auto-tiling engine. And I'm working on it in C99/C11, and right now what we're doing is we're doing a little bit of refactoring, where we're taking all of the polyfills that we wrote for our GLSL code, and we're putting them in their own kind of file. And if you're familiar with JavaScript, in JavaScript, a polyfill is, oh, this is an old version of JavaScript, so we have to inject this function that doesn't exist in this old version of JavaScript. That's what a polyfill is. And we're using it in the same sense, but what we're doing is we're writing C99 code, and we're testing that C99 code, and once the code has been tested, we want to take that C99 code and run it as GLSL shader code. And in order to do that, we have to make polyfills for things like Texel fetch, or make polyfills for things like IVEC2 or IVEC2 constructors, right? So we want to write our code in this really kind of like tricky, hackish kind of way where the code is both valid C99 and valid GLSL. And C99 and GLSL are very similar, but they are not the same language. GLSL is based on C99, but it's not the same language. It's very similar, but it's not the same language. It's similar enough that yes, you can just think of it as like modified C99, and you'll probably be fine. But you do have to realize that they are not the same language. Anyways, so right now I am adding the namespace for this. So it's called Polyogl. So for polyfills, and then OGL for OpenGL. And this system is the 26th system. So instead of doing something like dependency injection, I made a nice little build file here in C11 code that just includes all of the systems in this exact order. And when we compile, we can decide how far we want to compile up to. So when we say compile up to 32, that means we're going to compile libraries 1 to 32. Now, if we ever invoke some type of weird undefined behavior where the project seems to like be behaving very erratically, and we can't find out what's happening, what's going wrong, like maybe it like fails very inconsistently, and we have no clue what's happening, we can start to compile, we can do a binary search on this, right? So let's say something weird is happening in the project, we have no clue where that behavior is coming from. We could compile to here, and if that behavior goes away, then we know that the offending file is somewhere in here, right? And so then we can say, okay, so somewhere between here and here is our problem, right? So we could highlight this. So somewhere between here and here is our problem. And so then we could say, okay, let's compile somewhere in the middle of that. So we could compile this. And let's say when we compile up to this, the offending behavior comes back. And we know that here there was no offending behavior, but now here there is offending behavior. So now we know the problem is somewhere between these two things, right? So then once we know the problem is between 19 and 24, we can compile just up to library 22, and we can see where the problem is. And then we can keep on doing that until we figure out which library has that like offensive code in it. Okay, so anyways, I think I lost my viewer, but oh well. So let's keep on doing this. So we want to add this in a place that makes sense. So we see the Polyogl is after pixload. So pixload is right here, so we want to do Polyogl like that, right? Polyogl. And once we have that, we're going to take this this snippet here, right, this code right here, we're going to copy it to the clipboard, and we're going to use it to auto-generate all of the code down here, right? So we're going to just remake all of this code here. So we're just going to take all this ridiculousness, delete it, and then we're going to go farc, find and replace clone, and it's going to rewrite all that code for us. So if you were doing something like C++, you would be using templates, but we don't have it, so we're going to do this. Now, I could make some type of a build system that could do this and automate this process for me, but the idea is I want to make the code base really easy to follow and get rid of a lot of the abstraction. And the price for making the code less abstract is that everything can be very verbose. Things can be a little bit more clunky. Sometimes there's more friction in how you do things, but I want to make absolutely sure that the code base is as easy to follow as possible. And that's quite challenging. So now that we've put in those init none macros, that should be everything we need to do here. Now this reference is not guaranteed to be up to date, so I'm not going to deal with it right now. I know it's not up to date. We could try to put in the new thing, right? So yeah, there's like pixload is missing from here, right? So GPU data, right? So there's a whole bunch of things missing from here. We need to like resort this and whatnot. I don't feel like doing that right now, so let's just keep on going. So now we have f macros bottom, so let's look at this thing. So init none, we want to look at pixload, and we want to duplicate this and change this one to polyogl, and we're just getting rid of this function macro so that we don't pollute other people's code bases if they decide to use our code base, right? If someone wants to use this engine in their code base, we don't want to pollute their code with too many like macros, right? Okay, so now that we've done that, we're gonna cross our fingers and hope that these two stubbed in files are just gonna not make the compiler complain, right? So let's just see what happens. And see what happens. Yeah, let's see what happens. Let's run that build script and see if we're lucky enough to have gotten this on the first time. So extra tokens at the end of undef directive. So we did something kind of stupid. So let's go into our libchan order enforcer, and in anywhere we have undef, it looks to me where we defined, so defines and undefs. The undefs, we kind of forgot to do that, right? So while we're here, since we're already here, we might as well kind of like make a little checksum, right? So we're here. We might as well say, hey, well, how many of these do we have? How many things do we have defined and undefined, right? So we have 5 things here. And so the idea is when something breaks, we don't just want to fix the problem. We want to make it more, we want to make it stronger, right? We want to like a, it's like when you break something and you epoxy it back together, and now the broken part, the broken part now becomes the strongest part. That is kind of what I want to do. Now, why would I want to do that? I mean, it sounds good, but is there a logical reason for that? And there is a logical reason for that. The logical reason for that is a lot of times in code bases, the same bug keeps on popping up, right? Like a bug you fixed pops up later, like 3 months later, and it has to be fixed all over again. And we want to prevent breakage of the same thing twice, because that's kind of a waste of our time, right? We want to fix it once, fix it well, and then never ever have to look at it again. So that is the whole reason for if something breaks in our code, then we want to revisit it, make it even more resilient, and then hopefully never have to look at it again, right? So I had a boss who would often say, you know, once the code's done, I never want to have to look at it again. And I totally understand his attitude for that. So his attitude was, I don't care if the code looks ugly, because we're just going to get the code working, and then I just never ever want to have to look at the code again. And I totally understand that sentiment of never ever wanting to look at the code again. But unlike my old boss, I actually do like the code to look nice, even if I think I'm never going to look at it again. Now, where I do kind of agree with them is sometimes I make the code look really nice, then I have to come back to it, and I completely trash the code to get it working, and it looks visually it looks horrible, but I only wanted to step in here to fix some changes, and because of time constraints, I'm just like, screw it, we're going to leave it as a complete disaster. So sometimes, yes, I will leave it as a complete disaster and be like, you know, as long as it works, I'm okay. Now, but you know what, nice code that is both works and looks nice like this, I think is what you really want to strive for if you can. Okay, so we've kind of hopefully cleaned that up. Let's take a look and see if our build script works. So we have air extra tokens at, so we took all that time to do that, but then we kind of weren't paying attention, maybe because we were talking. But this needs to be like this, right? So we don't need those extra tokens, and then once again over here, same kind of deal. We don't want all those extra tokens. Okay, now over here, what's up with this? Why is this not correct? So 1, 2, and this is also a 1, 2. Oh, because the define is one space. I see. Now, did we make that mistake elsewhere? Did we do the... Yeah, we did make this mistake elsewhere, right? So define is one space in order to make it align with everything else we've written, right? So to make this line up with this, right, define is one space, and undefs are 2 spaces. I know that's kind of crazy, right, for me to say I know the exact number of spaces after certain words I write, but yeah, that's kind of like the level of meticulousness I put into aligning things. Okay, so let's give that another run, and I think that we finally cleaned it all up. So air operator less than has no... Operator, this has no left operand, huh? So what did we screw up here? So let's look at this. This is on line 88. So look at line 88 here. And did we do something like this before? Do we have a less than over here? Yes, we do. So we have define P0. Oh yeah, so somewhere while we were doing this, we completely nuked. Ah, man, we screwed ourselves over here, didn't we? So we got to take this. So this is, you know, Polyogl, right? And these ones are this is PAINT5D, and this is PAINT5D subsystem 1 OGL, right? That's what that is. The reason we do not less than is in case these are undefined, and the I'm pretty sure that like less than undefined would never evaluate to true, right? So if this is undefined, We just want it to, we want the statement to still execute in a predictable way to catch the problem, right? So if we don't define these for some reason, right, they're not defined because for whatever reason we still want this error to happen, if that makes sense. So okay, so we made this mistake. Let's let's kind of let's just do that. And did we do that for other defines? Did we screw up any other defines, or was it just that one? It looks like just that one I screwed up. And then the undefs look good. Okay, cool. So yeah, I mean, I screw things up a lot. So F macros, polyogl, init none. Implicit declaration of function, AAC 2020, polyogl, init none. Okay, so that is because we have not actually put that in here. So, paste init none function, right? So, there's my init none, and we're just going to say polyogl. So it's called init none because we always want to say, we want to say what we do, but we also want to say what we don't do. So when the system is starting up, I actually want to go through all the systems and initialize them. And if a system does not require any initialization code, then I want to say init none. That way we can still do like a roll call of all of the different subsystems and say init, init, init none, init, init, init none, init none, right? So we can check off every single subsystem while we're booting it up. And now if it's kind of like init none is basically the embodiment of when the teacher says, like, you know, when you're like elementary school or high school and your teacher says raise your hand if you're not here, right? They joke or whatnot about that. Well, we can actually do that. Init none is basically, you know, raise your hand if you're not here, right? So we can make a note of that, you know. So at vid iid 0114 time 129.13. Init none is the literal is the implementation of the saying raise your hand if you are not here, right? So that's basically what it is, right? So we can make a note of that at this timestamp and say that is what init none means. Init none is basically like a way to literally say, like, it seems ridiculous to say when the teacher says raise your hand if you're not here. That is kind of a joke. It doesn't make any sense, but in code we can actually make something like that happen, and that is what init none is for. Now, do we really want to keep this commentary here, though? Because we use it in a lot of places. I don't know if we want to keep this commentary here, right? I think it's just going to clutter things up. But we can worry about cluttering things up later, I think, if we... No, actually, no. We're just going to move this right now. And we can just say hashtag init none explained, right? So we can do a little hashtag init none explained. Right, so we can still kind of keep this pretty terse. And then we can go into our hashtag file over here. So in our documentation file, we have this little hashtag file we've been using. And we can just say hashtag init none explained. And then we can also say init none explained, right? So init none explained, right? And what is init none explained? And what is it all about? What's the whole purpose behind it? So we can take this. Let's put a little hashtag here, and then delete this. And there we go. So we just want to make a nice little section divider. And we'll keep this commentary that we wrote and just put it in here, right? So it's literal, yeah. So that's all it is. Okay, so here, let's make this a little bit more terse, though. Let's like, we've done this quite a lot to the point where I don't even feel the need to write, ini none how about init none how? So the thing is, sometimes we want to keep things terse, and sometimes that means we want to make synonym tags so that we don't go over this boundary and we can still keep things kind of terse, right? So we can keep this like this, and then we can just pack everything in here, right? We really don't care about being able to read this code because it's something we do so often, right? So I will forgo nice formatting to save space sometimes, right? So that's the thing why I can't use an auto formatter, because I think that formatting is like a very case-by-case kind of basis. Formatting should be on a case-by-case basis, right? If that makes sense. So we could say for init none how, we could say C init none explained, or C also. AAC 2020 some subsystem namespace init none exists, so we can keep a roll call of all subsystems when booting them up in order. Some subsystems do not have init code, but so I don't know if that's the best explanation, but I decided I would explain it one more time, since I'm here. That init none is basically like a roll call, right? And the inits and init nones are all done in a big chunk where we initialize or not initialize everything in order, all the subsystems. So it's kind of like taking a roll call or an inventory check of all of the systems and say, hey, is everything in here? Or like it's like a you know, we're trying to switch on the engine and we want to flip all those switches on, and we don't want to forget any of the switches. So if anything's omitted because it does not have an initializer, that might look erroneous, right? So if you have this big list of all the subsystems and we're switching them on, switching them on, switching them on, and then one of them is omitted from that list, we could be like, oh, we forgot to switch that on. But that might not be the case. It just might not have an on switch. Like, you know, we're going through our inventory and we're like, okay, we're in the kitchen. Okay, turn on the blender. Turn on the stove. Okay, turn on the microwave. Okay, turn on the knife. Oh, wait, the knife doesn't have an on button, right? Because it's just a knife. So some systems don't have any initialization code, but we want to be able to visually account for them in the source code, if that makes sense. Anyways, that's enough explanation for that. Let's just close this, and libchan order enforcer I think was doing okay. We explained some things. We made this a little bit terser, which is fine, right? So this is just, this right here is a no op, which we've done enough to where I know how that works. Yeah, so we're good here. So let's just try to run this. And we're just hoping that we have stubbed everything in the correct order, right? And it's very tedious, but Okay, so it looks like we got everything stubbed in the correct order, and everything is compiling again. Nice. Very cool, very cool. So, now, also I think that next time somebody random kind of shows up into the room, I'm actually going to open up my demos. Like, when it's a time like this, and it's like, if I really want the views, right? So if somebody opens up my channel, it might make more sense to show them on screen what I'm doing, rather than say, hey, go to this URL, because everyone follows the path of least resistance. And I gotta say, every time I'm looking at a channel and seeing whether or not I want to subscribe to it, I just kind of look at it. I never, like, check for any URLs in the chat or whatever. So I'm gonna remember that for next time. Because I think that, like, every time I see a random viewer kind of pop in, I think of it as, like, a attempt to recruit somebody, or to give an elevator pitch, right? So, now that we have all this stuff here, we got it stubbed in, and that's all nice and whatnot, we can start to move things around, right? So we have this new namespace, and we're actually going to start to actually move things around. So we're going to open up some stuff and find... is it an OpenGL hack code? Yeah, so we have these polyfills. And these polyfills need to be renamespaced. And put into where they belong. So do not paste into GLSL code. All this stuff has do not paste into GLSL code because of where it came from. And that's fine. Now, are all these just types? Are all these types? TextLFetch is not. These make functions are functions, so that makes sense. Okay, so here's what we're gonna do. I like this kind of thing here, where it's like, you know, oh. Whoa, geez, what the hell? No. Okay, let's just open it back up. So... let's just do this. GLSL polyfills, guard. So this is just a guard. And that's fine. We can keep that guard, we can keep this order enforcer. Right. So we can keep both of these, right? You can duplicate these guards. And the first thing we want to do is we just want to, before we even change the namespaces, we just want to put things in their appropriate spot. So this is just structs, right? These are just structs. So we're going to take these structs and say, okay, take them and put them here, right? So now we have these structs that we don't want to paste into GLSL. Do not paste into GLSL code because they are polyfills. Then we're going to go over to functions and say, hey, are all these functions? This is a function. That's a function. This is a function, right? So they're all functions. They do somewhat just work as constructors, but that's what they are. They're functions. So we're going to go over here. We're going to paste them in here, right? So now we have all these functions. And now, this file needs to be removed eventually. All right? Because it's just a distraction, right? Now, how do we want to do that, though? So let's see. We have hack code, right? So I think that the fragment shader code is I think this should have its own subsystem as well. Okay, let's just get this working first, right? So let's I want to make the system more flat, right? And so let's just make sure that moving that stuff around didn't break anything, right? And then if that didn't break anything, the next thing we want to do is rename space all of this. And then the next thing we want to do is say, how could we, so we have, you know, PAINT5D, and this is the OpenGL. And so what we also might want is a thing called P5D OGL. This is really, if you think about this, this is really the unit testing, right? So this is like this is really the test code if you think about it, and so we really need something that's like P5D FS, like for fragment shader, or OpenGL for OFS, like P5D OFS for fragment shader. OpenGL fragment shader versus tests, maybe, or I don't know. But these namespaces need to be reorganized a little bit, and so the idea is that we just want to move things around a bit so that we can get rid of the branching structure of the program, where we have a lot of things in these subfolders, and it's getting really hard to figure out where things are, because when we put everything in subfolders, all of a sudden the namespace is like, well, what's the namespace of this thing supposed to be? What's the namespace of that thing supposed to be? So we're trying to fix our namespaces a bit. So anything here we can start to kind of rename, right? So this AAC OpenGL whatever the heck, I'm going to go in here and we can just call this AAC 2020, and this is Polyogl IVEC2, right? So it's the same kind of deal, but we just kind of changed the name, right? So we're going to try to be kind of confident here, and we're going to say replace in files, right? So we're going to replace in files. And the file type is star.star, and we're going to do OK. Okay. And then we're going to do the same thing to here as well. So we're going to take this, and then we're going to paste it twice. And then we're going to change the namespace to Polyogl. And then we're going to replace in files, right? So we're going to replace in files, and hit OK. And we're going to keep on doing this. We're going to do a quick check here, though. We're going to do a quick sanity check and be like, hey, did we completely screw up anything when we did that, right? Like, do we have any weird macro logic that that destroyed that, right? And so it looks like that's still working. And so we're just going to keep on going through all these different namespaces until everything has been fixed, or everything has been normalized. So let's keep on going through here, and Control H. So we're going to paste and paste, and then we're going to call this namespace, this new namespace is going to be called Polyogl for OpenGL polyfills. So Polyogl, and we're going to say find in files. So this thing FV4 and FV4, replace in files, okay. Okay. And then we're going to go down here, and actually no, we got all of the types we have replaced, right? So if we look at our structs, we only have 3 structs in here, I guess. Yeah, only 3 structs in here, that's fine. And then in here, we need to do some crazy stuff here as well. So the first thing is this guy, this textile fetch thing. Let's paste it and paste it. And it's lowercase because of I get why it's lowercase, but it actually should not be lowercase. It needs to be... Now, we did texel underscore fetch just because texel fetch, I can never remember if it's capital T or lowercase t when we use camel case. Like, is it camel case or is it title case? So I just decided to call it texel underscore fetch, so I didn't have to worry about that. But let's just give it a... Let's make it public because other subsystems are also going to use these polyfills. So I think we should call it AAC 2020 and OGL, or Polyogl, right? So if we look at this, let's look at the names here. It is Polyogl, so we'll call it Polyogl texel fetch. So that actually makes it longer, but the thing is we absolutely want name spacing that makes sense. We could call it textfet. If we call it textfet, then it takes up the same amount of name. I'm going to do that. So we're just going to say replace in files. Okay. Textfet. And then another thing we're going to do is we're going to say we're going to go into our shortcuts really quick and make a note of textfet. Like, what does textfet mean? Right? So textfet, if we type it like this, we're going to say that we did a good job. And textfet means, right? So textfet means and if we do that, we just want to say, hey, texel fetch, right? Now, the other thing we want to do is if we write it backwards, right? So if we do fettex, or fettex, or fettext, or fet-text, or fet_text. We want to say that's backwards, and we want to use textfet. And so we just might want to make a note here that textfet breaks our naming conventions a bit because it has variable name style, but is used as a function. This is because it is a polyfill for GLSL, texel fetch, and I can never remember if it is called texel fetch or texel fetch or texel fetch or texel fetch, right? So I can never remember the case, right? So we're going to say in our code, when we want to use that polyfill, I don't want to have to think about it. So I'm just going to call it textfet, and maybe we'll regret that decision later. Like, maybe we'll decide that was a horrible, horrible idea, but for now, that's what we're going to do. Okay, so now that we have this, let's put this back over here, and let's give it a run, because we're going to kind of do a little refactoring, run it, do a little refactoring, run it, just to make sure that in our code that the refactors, that we didn't do anything completely stupid in our refactors. So that looks good. So we're going to just go through this thing now, and we're going to say this thing can be, you know, polyfill OpenGL, and we can call it Mac, and we'll call it Vec. Vec4 is technically FV4, right? Because it's a float Vec4, so float Vec4. So we just want to, yeah, so we want to normalize the naming here. And yeah, because we see FV4. So Mac FV4 for make float vec4. And that's also because one of the macros is called, the macro itself is called Mac FV4. So that's also why I want to call it that. So let's do find in files, make vec4, which is a float vec4 according to what we're looking at here. Okay, so replace in files, and okay. Okay, so now we want to do the int32 as well, so we're going to copy it, we're going to paste it twice, and then we're going to normalize the name convention. So the naming convention is going to be AAC 2020 Polyogl Mac I32, right? Because we're going to make an int32 here. And then we're going to replace that in files. Okay, so now we have this make function for int32s. Then we need a make function for the float32s. So once again, we're going to paste it twice, and then we're just going to change some things here. So it's AAC 2020 Polyogl, and then the make function is Mac F32. So Mac for make F32. So let's look at that. Does it make a float32 from an int32? It indeed does. And as long as we keep everything to int32s and float32s, we won't have too much trouble with this conversion. But sometimes this may eventually prove to be a yeah. We're never gonna convert uints to floats, right? So we don't really have to worry about this. Let's not worry about the places that this could screw up in the future. Let's just solve the things for now. So replace in files, and okay, cool. So now we have this nice little polyfills namespace that can be used for other subsystems. And now, when we want to know where like a certain polyfill comes from, well, it's in Polyogl, right? It's in Polyogl if it's a function, Polyogl.f if it's a function, Polyogl.d if it's data, right? And that is going to make it a lot easier to say, well, where is this file? Because we kind of keep on forgetting about where it's supposed to be. And with this, we're not going to have that problem. So now if we give this a run, we're going to hope that we didn't screw up anything. Okay, cool. So that's good and all. Now the next thing I want to do is we got the polyfills. I'm not really a fan of this fragment shader in this like hack code here. Like, do we want to keep hack code here, or do we want to keep do we want like something called OpenGL hack code, or want to be like I get the idea that we might want to consolidate the shader code eventually, right? We want to consolidate shader code, right? And so in here we might want to, you know, P51OGL shader code, right? So we might want to consolidate that, right? That makes perfect sense. So this polyfills thing is done here, right here. So we can delete that. So let's go in here for a second and let's delete the polyfills thing. Delete that, right? We don't need that anymore. Now notes and diagrams. This is really sure. I mean, that looks fine. So, OpenGL PAINT5D, whatever the heck, this deal here, that's not a proper namespace anymore, right? So, we know where that's coming from. So, we can go into... so, let's try to fix some of the things that are... Oh, crap. So, let's try to... find the files that are kind of... So in PAINT5D, in actually the PAINT5D OGL, like these files here, I believe we have, did that not open them? Yeah, so these files here, what the hell? Hold on. So this file here, I believe we have a bad like namespace in here, right? So if we look at if we look for this thing, I'm guessing it's in here, like this kind of namespace. So OpenGL PAINT5D get, right? So it's the OpenGL version of certain functions, except now these namespaces, instead of call it OpenGL PAINT5D, all these functions really belong to a different namespace. So this functions file, and then so it's in hack code, is it? Is it in hack code? This isn't even where the code is. I see. Okay, I see what's this. So, I think that in this case, we should just keep the function file separate from the unit test file. So usually you want the unit test file in the same folder or in the same file, but the idea is that this is fragment shader code, and we want it to be kind of separate. Now, okay, well, let's not worry too much about that problem right now. I just want to say, if we look for this OpenGL PAINT5D kind of thing, yeah, we get the same thing here. We get all these things called OpenGL PAINT5D, whatever the heck, right? And this namespace that's OpenGL PAINT5D, like everywhere it is, it looks to me that what OpenGL PAINT5D is that's really like the, it's the PAINT5D namespace, but it's PAINT5D code specifically to be ran as OpenGL code, and we've decided that it's going to go in this thing called P5D10GL. And we kind of screwed up our namespacing here, where it says OpenGL. Well, the pattern is supposed to be project namespace, subsystem namespace. And this totally confuses us, because it says OpenGL PAINT5D, but it's not in the PAINT5D folder, right? In the PAINT5D file, right? So we need to fix that. So anywhere we see, at least we're consistent with our naming, so that we can just say AAC 2020, and we can say P5D1 OGL, P5D1 OGL, and that's it, right? We're just going to change that namespace to be more consistent, right? So we're just going to go find in files, and we're just going to replace everything with AAC 2020 P5D1 OGL. O as in O, not as O as in 0. So I want to make absolutely sure that's an O, because 0 and O are very close to the keyboard, so sometimes mentally I just make that mistake. So find in files, and we're just going to replace this in files. Okay. And now P5D OGL, whatever the heck. So now, we want to still make sure that this works, right? That the code still compiles. And we made one mistake, is that by changing this OpenGL hack code thing, right? We did a mass find replace, and so we did screw something up in one position. Yeah, line 100, this include has been broken, right? So we want to just take so this thing just needs to be changed. So fatal error 100. So if we look at line 100 here, and look at the includes, what do we do here wrong? OpenGL hack code. Oh, because these polyfills don't exist anymore, right? The polyfills are now in a different folder, right? So polyfills. So let's make an update here. So that's actually not from finding or replacing. So 0114. Polyfills are now their own. Time is So polyfills are now their own subsystem. C. And so if we want to see that in the library, it's called Polyogl. C lib slash Polyogl dot, right, dot star, I guess, right? So we can make a note of that, so that's actually not too bad. Okay, so let's give that a run and see if we can get this working. And we just want to reorganize these files because everything's kind of a mess. Everything's kind of like all over the place. Okay, cool. So now we're back here. And the next thing we want to do is we want to think about, so let's look at this project structure again, because the project structure is still kind of a mess because we got this OpenGL hack code. And let's look at the namespace in here for a second and think about, well, what is this? Well, it's in AAC 2020 P5D 1OGL. And it's really the actual implementation code, right? And this function file is actually, if we look at it, it's all test code, right? This whole file is just test code, right? So we got these logging functions, right? It's all this stuff here. So I think what we want to do is we want to figure out, well, how are we including this, right? It looks like we're including it as right here. I think somewhere we had a include for that. Yeah, OpenGL hack code, and here's our fragment shader code right here. So it's coming before the init none. It's coming after the init none. So I think what we want to do is we want to say, like, we want to include, when we're including the functions, we want to include dot f for the functions, then a non-standard fragment shader kind of code, and then or you know what, we could say we really want this fragment shader code to be its own file. We want it to be its own file so that if we want an automated build system, we can copy paste it. But it doesn't really make, to me, I don't think it makes sense to be in its own folder here. Like, I would like to get rid of hack code and not worry about it, right? And then we still have, like, PAINT5D default shaders. That's where that code is. And then we have this thing called PAINT5D, right? We have way too many things called PAINT5D. So what I would like to do is just get rid of all this extra stuff, right? Let's PAINT5D this, PAINT5D that. That's too much for me. I think we need to flatten this out a lot. So I think what we can do is we can libchan, right? We can hide some of this irregularity in how we structure libchan, right? So libchan, and we look at libchan top. I think that's kind of where we should do this kind of stuff. So if we look at libchan top, and we look for, you know, P5D1OGL, and look for that, and the data file is fine. It's the function file that has kind of like a whole bunch of nonsense going on. And I'm thinking we include the function file and we include the fragment shader file as well. But it's just like a it's just like S for shader, or so I think we do this. Function code, shader code, and test code. So function code, shader code, and test code. So fs and test. Right, so I think because it's if it's a non-standard extension, we want to say we want to give it something that kind of like makes more sense. So we could say UTC for unit test code. I think would make more sense because UTC is something we use a lot. And then we could say this could be FS for fragment shader, or we could call it FRA for fragment shader, like that, right? Something like that. I think that's the way to go. Now, do we want to do it like that, or do we want to call it F_S? I don't know. All right, and the idea is that they all exist in the same namespace, but we're just kind of splitting it up into kind of these logical smaller units. And we don't always do this, but in the case of this, just because of how we want to organize this, it kind of makes sense to do that, right? So actually, let's do that. So let's get on that. So let's take this code here. And this is the main function file. And then over here we have this kind of nonsense, right? We're gonna like, kind of like, right, so this stuff comes before. So here's what this is. So this is going to be completely removed. Okay. So we're going to delete this out of here. And this is technically the FS file. This is the fragment shader file. Alright, this is the fragment shader C99 file right here. Because right where we have this include here. So that's basically what this is. And then this is helper functions for unit tests, and then just unit tests, right? So helper functions from unit tests, and then unit tests. So we're gonna go file new, and we're gonna just steal the unit test code from here. So in P5OGL whatever stuff, right, okay, yeah, so this is true. Okay, yeah. So we're gonna take all of this. So some of these functions may not always be unit test helper functions, but yeah, so this is a lot of stuff, right? So now, ideally, I don't always want to break it up like this. The only reason we're breaking it up like this is because, hold on, P5D1 OGL dot UTC unit test code. P51 OGL unit test code. The reason we're breaking it up like this is because we absolutely want the fragment shader code in its own file. Absolutely, that's for sure. And unfortunately, the fragment shader code kind of comes after kind of like these basic functions. It comes after that, and then it comes in the middle between this boilerplate stuff and the unit tests with how we've written it. And because of that, it's kind of... Because of that, it kind of makes it just easier to split it up into 3 files with how we're refactoring it. So usually we wouldn't do this, but in this case, this is how we're doing it. So now we can just save this, right? And we'll delete this stuff here or put it somewhere else later. So this is in init none. And now what we're going to do is we're going to take this FS thing, and we're going to close it, or we're going to open the containing file in Explorer right here, not Internet Explorer. And we're going to just rename it. So we're going to rename it to frag. And this says notes and diagrams. Do we already have a notes file for this, or do we not? So if we do P5D1OGL, we already have a notes file, don't we? So what does it, so we could combine that, right? So, yeah, I think we just need to combine it, right? So, I think we just combine that, and then we can get rid of it, right? So let's combine it now. So let's go into the code here, and this is our notes and diagrams file, and we can just take kind of like nad notes and diagrams. We can take this kind of stuff here, and we can say notes and diagrams. And then yeah, let's not get too many notes files, right? So nad is notes and diagrams, but n is usually what we use for notes. That's fine, right? I think only one notes file is fine enough for any given system. I think any more than that just makes it too granular. So now we got UTC, and this notes and whatever thing, we can delete that. So you can delete this. Then this fragment thing, we're going to move it, right? So we're going to take this, and we're going to go cut. We're going to go into the main library, and we're going to paste it. So we're just going to paste it. Then we're going to hit F5 to refresh, and then we're going to look at P5D, whatever the heck. So P5D, they're right here. So we got the diagrams, we got the functions, we got the fragment shaders, we got the notes and everything, right? So very flat. But the idea is that we can look at this, and we can immediately have a high-level overview of all of the PAINT5D OGL kind of stuff, right? And that kind of flat layout is better than having all these deeply nested folders where we're kind of going to lose track of all these little pieces. So now what we can do is we can take OpenGL hack code, and we can just delete this folder. And we still have this thing we got to deal with, but before we do that, we've made a lot of changes. Let's just make sure we can get this running first, because we kind of moved a whole bunch of stuff around. Kind of worried about moving stuff around like that. So let's just make sure that everything indeed is in place and looks good. Okay, so now that hack code, I know exactly what that was. So what we're going to do for that is we're just going to say, we're going to go into the lib, and this is kind of like, we don't want a dedicated folder. We don't want a dedicated folder just because we have this one hackish piece of code that was included for a unit test, and oh boy, right? So I think that since this is for unit test code, right? UTC. So what we're going to say is we're going to call this, we're going to rename it. So we're going to close this. And we're going to find where this is first. So it's going to be in the unit test code. So if we look for Control F hack 001, we're going to be able to find it. So yeah, this is the only place where it is. And we're just going to rename this to something like something that gives us more information about what this is. So how about P5D, so PAINT5D, 1 OGL, UTC, dot, unit test code, dot hack, right? It's just hackish, right? So we can keep the hack to note that that is what's going on. And now we don't have to have it in a PAINT5D folder, but we say it's P5D1 OGL, OpenGL, dot unit test code, dot hack01, right? So the idea is that I don't really care about giving it a specific name. It's just a hackish piece of code that's been included, and it's ugly, and it's a hack, and let's just make sure that we know it's ugly and it's a hack, and it belongs specifically to the unit test code, right? So we've purposely taken this code out of here, out of the function, because the function is getting gigantic. So we thought, hey, we could just remove it like that and go on our merry way. So now we can copy this, and then we can paste this right down here, right? So we can go paste, right? And now let's just make sure this still builds. So let's go back over here. Let's try to build this. Okay, so it looks like it's still building. So we got so we've been able to refactor it nicely. And now, inside lib, this PAINT5D folder, we can get rid of it. Like, we only want one PAINT5D folder as far as I'm concerned. Now, the idea is that right? We can talk more about it, right? We can say we might want to give some information about what it is, so we can call it PAINT5D default shaders, right? And then we have fragbed default shaders, right? So having it like that kind of makes sense. And so now what we have is, for this kind of file, we could eventually we could use our build system to auto generate this source file, right? Because we could take we can take the fragment shader file. So this fragment, let's open it up. So let's find out where you are. So let's open up the fragment shader file. So P5D and the fragment shader file. Right, so P5D1OGL. And we know we want to cut and paste this into these files here. However, we might actually want to, if we want this into a actual build system, then the easiest way to do this is to get rid of this commentary, right? And now the thing is that this commentary is kind of nice. I like this commentary here. I think it's helpful. So if that's what we want to do, if we want to keep this commentary, we can keep this commentary, but we're going to have to condense it like this, right? And then we could also kind of like, if that's how we want to roll, we might want to just make this like more obnoxious, right? So these three things here. And we might want to keep this payload kind of indented like this, so that way if we use our build system to kind of cut and paste this code into the shader code, we don't have any weird indentation issues, right? So now we can use this. Therefore, it's formatted more properly for a build system to automate this, or for us to cut and paste it. Now, the other thing we want to do is for this to really work for us, we're going to have to get rid of this nonsense, right? Right? If we want to have some type of file where we just can cut and paste from it, then we can't be keeping this stuff in here, right? We can keep some variable explanations in something else, but this stuff here, we're gonna have to put it somewhere else, even though it kind of wrecks our Control F help if it's not in the same file. But if we want this to be nice and clean so that we can use it as an automated way to generate GLSL files, then we're really gonna have to dump this stuff into the notes file, right? So we'll just dump this stuff into the notes file. Let's not worry about the exact organization of this, right? Let's just dump it in the notes file, worry about it later. I kind of think that the most useful thing for the notes file is probably going to be these signatures of these functions, unless we have some type of very nice diagrams. So function signatures. This is already called function signature, so let's kind of add to that, right? So we can add this one. And yeah, so we've moved everything around, we've shifted a lot of stuff around, but now we have this nice little payload that we're ready to edit and make adjustments to. And then we can paste it into here, and then we can run it. Let's just make sure that this runs, and then maybe we'll add a script to our build system to automatically cut and paste this code into the project, which will save us some time. So let's first let's run this, and then let's maybe look up how to cut and paste code into a project. Like cut and paste, like how do we cut and paste this code into, right, okay, so that works. So the question is, how would we automate the process of taking this file and cutting and pasting it before we compile it, right? And so that shouldn't be too hard, but we're going to have to think about how to do that. So, for example, in lib, if we look at the library and how we're doing that, PAINT5D default shaders, so this thing, we actually might want to create some type of template file where we create, this is the first thing we want to take, and then we include this, and then we paste this in there, and something, right? So this is a source file. So I want to figure out how can we reconstruct this source file and like just paste this from a different file, right? And the thing is we can't just do an include, can we, right? Because we have to stringify it, right? Now, could we... Yeah, that's the only way we're going to get it working. So we want to somehow paste a file in every line we want to surround like this. And I don't actually know how that's done, but that could actually really save us some time. So let's just go over here and let's commit what we have, right? Because we did a lot of refactoring. And let's say git status, git add dot, git status, git commit dash am. So flat is better. So we refactored. We refactored, and flat is better than nested, right? So make a useful message. People saying to say why you did what you did, or what, right? Don't worry about the exact message. Just make sure that it's somewhat useful, right? Like, make a useful message. I think that some people say the only useful message that you should ever put is why you did what you did. I think it's okay to say what you did, or maybe why you did it, or something else that is informative that gives you some piece of insight that's not immediately noticeable from just looking at the files. So if it's something, and maybe it's not, or maybe you could derive what I did by looking at the files, but by giving a little hint to speed up, we just want this. We want the commit message to speed up some type of mental process, right? Whatever is most important for somebody to know for this commit is what we want to put there. And we're not going to use some type of a hard, fast rule of the most important thing is why you did what you did. Because why you did what you did might be obvious in some cases. And so you might want to say something else. Like fixed a bug. Do I really need to say why I fixed a bug? I don't think you do. So, I don't think we should adhere to dogmatic, hard, fast rules. I think we should just put something there that's useful, right? So make that. So I think the requirements for what a good commit message should be a little bit more open-ended. Okay, so let's try to figure out how we're gonna surround this in quote marks, because I have no clue how we're going to do that. And actually, before we do that, let's push this up to kanji coder, because it actually works. So git push kanji coder master, right? So everything's compiling. Everything's in good working order. So let's kind of like paste that, or not paste that, but push it up to kanji coder. And then let's think about how we're going to write a bash script where we can enclose things into quotes and get it working. Now also, no, that's fine, never mind. Yeah, so I want to figure out how we're going to enclose, we want to be able to take this code, enclose it in quotes, and create a file like this. Or technically not this file, because we want to create just the quoted part, right? But we want to auto-generate the quoted file. So we've backed it up, so if we screw up anything with a bash script, we're not going to be up a creek without a paddle. And let's go on Facebook and see if any of our see if anyone knows how to. I should be working. Yes, I should be. Midori run. Let's run Midori, because I don't have a Facebook blocker on that. So I try to make sure I don't use Facebook too much. So if I run out of time, then I have to go use this browser. The idea for that is to make sure that if I know I'm out of time, sometimes I'm wasting time. It's like, well, I have nothing else to do, and I know I'm going to waste time, so does it really matter where I waste time? I don't think it does, so fine, waste it on Facebook. But we want to not waste our time on Facebook if we're supposed to be doing something else, right? So that's why I have these blockers. But right now, sometimes Facebook is useful to where you want to actually ask somebody how to do something. So anyways, we're going to take this, and I'm just gonna make an update, I guess. Because people have already been posting on my wall anyways, so... anyone know how to write a bash script that takes each line of the file and surrounds the line with quote marks? So I don't do much bash code, so it's nice to just ask, bash, how would I pre-process a source file to surround each line with quote marks? Okay, let's also go to LinkedIn as well. So www.linkedin, and I might not actually be logged in Midori, right? So let's just go in our other browser, because I don't think my Facebook blocker is on LinkedIn. It might be, because LinkedIn is also a time waster. It's just where you pretend not to waste time, but you're still wasting time like Facebook, but you pretend not to. Or at least that's kind of how I've seen it. But yeah, we can also ask here, and I guarantee I'm going to get more answers on Facebook than I am LinkedIn, because everybody's just trying to act smart on LinkedIn. So nobody wants to sound stupid, right? Because I'm asking, I'm basically admitting that I don't know something, so people aren't going to ask questions like that on LinkedIn, because they're trying to suck up to employers. And how can you suck up if you admit to not knowing something? And then people aren't going to answer me, because I think they're like, either they're just all idiots, or well, that's probably not true. They're probably not all idiots. There's probably plenty of smart people. I actually have friends on here that are very talented, or skilled and knowledgeable. So let's be less harsh than that and say, no, they're not. It's not that the people here aren't smart. It's that they're afraid to look bad in front of recruiters. Or at least that's what I think's going on. Now, maybe it's just that nobody likes me and nobody wants to help me, or something else like that. I don't know. Could be a lot of things, but we don't really care, right? We just want to get some answers. Yeah, like I said, plenty of smart people on LinkedIn. It's just that I can't, for some reason, Facebook gets me better answers than LinkedIn. So we can hypothesize as to why that is, and some of our hypotheses can be more or less offensive. You are a serious... Anyways. We're good there. Let's, so I know that we have there's some type of bash program that kind of processes every single line. And it's like, I don't know what the hell it's called. It's not grep. It's called, like, awk. It's called awk, I believe. Bash program that processes each line. Processes each line. Process each line. Process each line AWK. Try. So we're going to make an example in awk. Because I know awk is pretty much what I need to do. So let's kind of like... So we're gonna make a folder for an example in awk, because I know that's what I need to use. I don't know exactly how to use awk, but I know it exists, and I'm pretty sure that that is the solution to like making our build script. So let's go in here and let's go into our AutoHotkey folder. And shortcuts, SC files, let's look at bash. Awk no match. Oh, so we even have an awk demo, so that's nice. So we have an output, huh? We have an output. Hello 1, 2, 3, and we have story.txt. So it looks like it's just going to take every line that has hello in it, right? And that's fine. So let's make a kind of thing. So let's take a thing. Let's take this open with Notepad++ really quick, and let's just take a look at this demo file. And we have a concat example. So touch out.txt. We're going to create it. We're going to clear the file. And then awk, we're going to take this hello file. Or are we taking the hello file? No, we're looking for hello. And then we're kind of like doing this kind of thing here. So story.txt, out.txt, and then this is just concat, and this looks like we're matching. This is why I don't want a complicated build system, because when I look at this, I'm like, I don't know what's going on here. Awk use include. So we're going to look for use or include, and then next. So no includes.scad. Okay, got ya. So it's like a little script to help us remove include statements, and I can see why I wanted something like that. Okay, so yeah, awk is definitely what we want to use. Now this is not the exact example of how we want to use awk. So I think what we're going to do is we're just going to go new, and we're going to say awk awk quarter, right? Awk quarter. And we're going to figure out how to use awk again to do so right here we're going to say awk quarter. Let's call awkquo.sh, whatever. And then awk quo is awk quoter, right? Awk quoter. Wrap a file in quotes to create a what do you call it? A string literal for C99, C11 source code, right? So that's kind of what we want to do. And we have no clue how we're going to do this. We need to kind of look at how awk works and figure it out from there. So, first of all, we got way too many things open here. You know, let's keep it down to like 2 folders at most for now. And let's just move this. Now, if I move this over here, do I actually lose my... If I move this over here, do I lose my editor? Because I've been losing my editor sometimes, and I'm wondering how that happens. Okay, so that's what happens when I accidentally delete my... When I accidentally delete one of my editors, that's why it's happening. Because I was wondering why that was happening. Okay. So now, we've kind of reorganized. So we want to take this file right here, and we want to pre-process it to surround it in quote marks so that we can get so let's look in here. So PAINT5D default shaders. We want to pre-process it so it gets this big shader string here, right? We want to take all of this, pre-process it into this, and dump it into the correct file so that we don't have to keep on doing that tedious nonsense, right? We can do that. Now that requires that we're going to have a more complicated build script, and we will still commit the file that is generated by the build script, because technically we could manually do this as well. And the idea is that we don't want the build script to be too complicated, and we are getting a little bit complicated if we do this. So, okay, so now let's actually look for awk, right? So let's go over here and say AWK surround each line. So I know that we want to kind of do awk surround wrap each line. Wrap. So I'm just making some shortcut entries here. And you can't see this because I'm still working on it. Okay, so how to put each line with quotations. So this is basically exactly what I want, right? So this is exactly what I want to do. So upvote that, and we should just be able to use awk for this. For the wrong reasons. If you have a program which requires its arguments to be in quotes like tool, example, sentence 1, example, sentence 2, the quotes are consumed by the shell and not part of the data itself. You have those values in variables. The variables should not contain the quotes, but you need the quotes for interpolation. Yeah, so not the case. I have reasons for why I need to do this. I want to use awk. So let's see. The awk command seems to be within single quotes, and then we do print, and 0 is the replacement token, right? So it takes that line, and it's in a quote escape sequence using pure bash. So we can use pure bash. So that's nice with the pure bash example. Now, which example kind of like is the most portable, right? If your file is empty lines, awk is definitely the way to go. And we do have some empty lines. So if we can get awk to work like this, then I mean that's all we want, right? Yeah, so it's awk. Awk is the way to go here, I think. And so what we're going to do here is we're just going to take this thing here, and the input file needs to be some type of text file or something, or some type of text file. So we're just going to say, like, input.txt, right? We're going to name it something that actually makes sense, right? And then we're going to do new And we're just going to say, let's just take some stuff, right? So let's take some of this stuff, right? Because it's, ooh, what the hell? Yeah, let's take some of this. And we don't need it all, but we can just take some of it as a little example, right? And not worry about, right? Because it's going to be kind of centered like this, and it has some blank spots on the top and bottom. We don't need the whole thing, the whole shebang. We just need this. And we'll use this as our input.txt. We'll save this as input.txt. And how does it output here? So awk, I'm going to guess nf is the output file, maybe? Or I don't know what nf is. What the heck is nf here? Let's look at this for a second. So awk is the answer, definitely the answer, but what is the nf? nf tells awk to only execute the print command when the number of fields is more than 0. Line is not empty. I mean, that's fine. That's actually kind of how I want to do it. Now, where's the output file, though? Well, I would like to output this to a file, so output to file awk. Awk whatever text.txt, and then okay, so we just direct we'll direct it to the std out file. And this will append. Okay, got ya. So that's what we want to do. So people who know what they're doing, right? This makes sense. So I think I'm going to answer this question with the revision, because that answer is the best answer. But I think that I could improve this by doing like a little YouTube tutorial and putting it up on the internet and explaining it more concisely. I think because when I go to Stack Overflow, I just want to look through it and be like using awk. And this is a pretty good answer. It's almost what I want, but it doesn't do exactly what I want, right? So, like something where it's like, sure, if you actually want to retain / escapes. Yeah, let's just roll with it. Let's roll with that. So all we want to do is go like this and do output.txt, right? So it'll create that file if it doesn't exist. And we will answer this better 2021. So we're gonna re-answer that Stack Overflow question with our improvements, I think. Right, because we want to get some cred, right? But yeah, let's open the containing folder in Explorer and let's just give it a shot, right? Let's just double-click this baby and see if we can get something decent going here. So press enter to continue, okay, and let's see if it looks like complete crap or not, or what it looks like. So output.txt, let's see what that looks like. That looks pretty nice. All we need now is to indent it by, not indent it, but we need to add backslash, so right here, we need to add /ends, right, to get that working properly. And if we do that, then I'll be kind of satisfied. So, but we're close, so let's look at the awk script and see that Looks like the escape sequences we have, this is an escape sequence for the backslash, right? So, backslash double quote itself, sorry, this right here is an escape sequence for the quote symbol, right? And now are we able to, do we have to do it with, oh, we do, because we have the single quotes here. This is ugly as heck, which is a lot of bashes. So, quote symbol, but before we do the quote symbol, we want to do a backslash. We want to do a backslash. We want to escape a backslash, yeah? And then we want to do literally an N. Yeah? Let's do that. Let's give that a shot. So let's double click this. And look at the output. Not exactly what I wanted, right? We got the backslash, but we don't got the N in there, do we? Okay. So what the heck are we doing wrong? Do we need to quote the N? Does N need a quote? Like, it needs to be quoted? Maybe. Oh, that is ugly. Oh, let's try it. Let's try it. Let's see if that works, right? So, I can see why that might need to be quoted like that. Let's close that. Look at the output now. Nice! So we got the backslash N. And yeah, so it's in a nice string. Now, I don't like the backslash N being kind of put up right next to there, but I mean, it fits. I mean, because I originally wrote the code so that we could actually put the quotes right over here. Whatever. I mean, that's pretty good. That's a pretty good result. So let's just roll with that, right? So yeah, this is kind of what we need. And so let's take this and awk quoter, so full file path to clipboard. I'm going to take that and put it in my shortcuts. And then also this one-liner here, I'm going to take this as a one-liner because I can use this. And I'm just going to awk bash quoter paste. Awk awk bash awk bash quoter paste. And I don't know if that is going to work if I paste it, because it has a lot of characters in it that don't look like they're going to... So let me put this over here for a second. So this nonsense here, there's a lot of weird stuff in it where it might not paste properly, so we don't want to put it over here, and then just open this up, and go into our AutoHotkey folder, and go into shortcuts, and then SC files, bash, and snip. Well, I guess technically we're in bash, so we want to go awk bash quoter, and just do like a awkquo dot snip, right? Or oh wait, we're not trying to open anything. Hold on. Copy that, and just file, say, god damn it. Take this path, put it over here, save this as awkquo.snip._. So this is going to be the snippet file, and then we can take this code here. We can just paste that right there, and we can say input.c99, right, or c99 or c11 or whatever. Just I want to make a note of the implementation, right? That's the only reason I'm doing that. And output dot dot include output. You know what? Let's not do that. Well, actually, no. Input.c99, output.txt. That kind of gives me a clue as to the implementation details. That'll help me. And then we'll put this here, and we'll kind of paste it here. So now, if we ever want to use this awk bash quoter, we can do that. Now, abq paste. abq paste. So make some other synonyms for this. And we're actually not going to paste line for this. Paste line would be if we're pasting the file path, but we actually want to paste the file. So paste file. We want to paste the file contents. Okay, so now we have that kind of snippet for the next time we ask this question. And now we want to implement this into our main kind of script here. So I guess we could keep this open. I'm going to put this that Stack Overflow tab somewhere for later. And now I'm going to look at the build script and see how we can modify the build script and be like, okay, that's kind of crazy. I really don't want to modify the build script and make a fancy build system, but the time has come. So all we're going to do is now we should be able to quote these file paths, I believe. So we should be able to, well, we don't have to quote them, but we can do something like, so when you access a file, you put a $sign around it, or how does that work? Let's look at a bigger bash file, hkmf clunky. hkmfc11. So this should be the clunky version, yeah. So, okay, yeah. When we access a string, we put the $sign in it, right? When we assign it, we don't use the $sign. So the $sign is used for access. I just wanted to make sure I knew that so that I could do this properly. Because I don't write much bash script, so yes, I do forget how it's written because I just don't use it that much. I just use enough bash script to get by, right? I just want to like run some commands that I would otherwise have to type out, right? So just automate some basic, simple things, right? So we're gonna look for hkmfc11 right now because it's the clunky version that is here. So hkmfc11. Oh, it's even called clunky. So you're telling me I called it hkmfc11 clunky, and then I didn't even have a shortcut called hkmf clunky, huh? And did I do that for... if I do hkmfc11 clunky, though, do I get something? Okay, I get it there. It's just that if I do hkmf clunky, I don't get anything, right? So we're gonna go over here and also make another entry here. We're gonna call it clunky hkmf for clunky hackish make file. Clunky hackish make file C11. So the idea is that I don't actually use make files. I just use bash scripts, right? So I say that it's a hackish makefile. Hackish makefile, HKMF, stands for hackish makefile. And the idea is that I don't want a complicated system here, right? So I don't want any more complication than necessary. This is a time-saving complication, so we're going to do it. So the way we're going to get this going here, though, is we're going to say that I equals, I believe we don't have to declare it, right? We can say in you can say in equals, and then say from this folder dot slash lib slash p5d 1 ogl dot fs, right? So this is the file we want. This is the input file, and the output file so let's just keep it kind of simple, right? Flat is better than nested. Let's just call it P5, let's just call it string, and it's just going to be the stringified version, right? And then here, where we have the input, we're just going to go $sign in, right? We're going to access what's there, and then same thing here. We're going to do $sign out. $sign out. Okay, that's all we want to do. And we just want to see if we can get that working as is. So let's give that a shot. Let's close all this. Let's close this as well. Let's move this over here, I guess, to this side. And let's hope that we don't nuke anything. So let's actually get bash here for a second. Git status, git add dot, git commit -am. This is going to be a safety save. Never know what bash can do. So the idea is that bash, running a bash script on this project may do something completely catastrophic. Now we're hoping not. We're betting that it won't, right? Because this is just a one-liner, and we know what we're doing. We've already tested it out once, but I'm kind of paranoid. Like, I don't, like, what if I accidentally overwrite the file? Like, what if I get this wrong, right? And I swap the input and the output, and then we delete our code file, right? And then everything is, like, completely wrecked, right? So we don't want to do that. So we're going to do this like that, and then we're just going to double-click this to run the project. And then after we've ran the project, we're going to see if, well, there we go, can an open file dot / lib, whatever the heck. So it can't open the file. For reading, no such file or directory. And so, first of all, the question is, what do you mean, no such file or directory? What's up with you? So let's look at that for a second. So in lib, don't we have like a P5D? P5D 1 ogl dot fs. Oh, it's not dot fs anymore. It's dot fra for fragment shader. That file exists though. So let's delete this. Let's open up first. Nothing in there. Let's delete this. Delete. Yes. And let's just change this to fra for fragment shader. Okay. And yeah, fra for fragment shader. And now let's give that a run, right? So let's give it a run and just see what happens, right? So we're gonna, that's probably the only mistake we made, I think. And if we give this a run, we can create like an automated kind of build system to do what we need to do here. So let's give that a run and hope that finally we have done the research we need to save ourselves time in development. So now let's close this. Let's go into the lib folder now, and let's look for the P5D whatever, and we have this string file, and let's open up the string file, and it looks pretty good to me. Now, well, it looked pretty good until we got to here. Okay, so that's still good, it's just ugly, right? Because we didn't put the, so there's some parts that are kind of, that's ugly, but it's pretty close to what we want. So what we're going to do now is we're going to be like, you know what, we could have screwed something up royally. So let's go into the lib folder, and let's go into the default shaders, and let's just call this one, let's rename this to version 3. Okay. And then let's open this up really quick. Copy it. Copy the contents. And then file new, and let's paste this contents here. And what we're going to do here is this new file, what we really want this new file to be is, instead of having this directly cut and pasted in here, we just wanted to go like this, include, and then we want to go, we're in default shaders, we want to go // right? We want to go back one, and then we're going to include P5D1 OGL dot string, right? Right, so we want to include that generated file. And then bam, we have like a little awesome shader thing, right? So PAINT5D default shaders. And we just call this, you know, P5D 001 dot underscore, right? So there's not, come on. No. God, sabotaging me here. So let's open this up and do that whole process over again. So lib, it told me it was already, whatever, let's not worry about it. I'm not sure if that was my mistake or Notepad++'s mistake, right? But I can see why that mistake was made. So, okay, so now we have this new version of the file, and all it is the same kind of deal, but instead of mindlessly cutting and pasting and wasting all of our time, we're just going to include this directly. And because this is included here, and it's inside of a string literal, we'll be able to build this, right? And we got this, the proper kind of header stuff to make sure that it's interpreted as OpenGL code. So we're going to try this out and see if the project still compiles. And also, if we want to do this properly, if this is actually what we're testing, we actually have to go into the mod folder, and we have to delete this first shader, right? Because this is the one we want to recompile. And now let's cross our fingers and hope that this kind of awk solution worked, right? So we're trying to automate what we've been doing by cut and paste, and we don't think we've screwed up anything, but there's the potential that we have, and so let's just run it. And so nice, excellent. So there you go. So now the next thing we might want to do is, do you want to reload it? Sure, yes. And the next thing we might want to do is we might want to look at this fragment shader and be like, well, is this actually what we've ran, right? And we want a little confirmation about that. So let's just say, let's just add hello world. Right, so let's add hello world here. And now we're going to rerun this thing here, and it should rebuild the whole thing, and now we should be able to find hello in the generated shader. But however, in order to do that, we got to go into the mod folder, and we got to delete this. Now we could also kind of automate this process as well, but let's not worry about that too much for now. So let's build this up and see what happens, right? Okay, so there's still a shader here, right? And the next thing is, well, okay, there's that shader there, sure. But in the mod folder, it regenerated this file. So the question is, if we go in here, do we indeed have... Okay, so this is kind of not indented as I thought it would be, but if we go in here and we look through this, it all looks pretty good. Do we see the hello world in here? Boom, it's right there. Awesome, awesome. So what we have done here is we've made like a simple kind of build system here. And yeah, so right here we might want to make a note of this, right? So generate GLSL code from C99 code, right? So that is what we're doing. We're generating C99 code, or we're generating GLSL code from C99 code, right? So my formatting here sucks. So my convention is to kind of like in Bash script, I usually use 2 hashtags as a comment character, even though it's only 1. And that's kind of like how I've kept a thing. So there we go. So we have this kind of comment here, and this is our build system for all this does is surround every single line of the file in quote marks. In quote marks like this. Original. Some line of code. So let's say, input line, outline, some line of code, \n, so we can automate process of creating GLSL code from C99 code, right? So that's what we're doing. So we can kind of surround that a little bit, and we can also make a note of that. So the video ID, right? So at vid IID. So the video integer ID of this is 114, and the time is 3 hours, 7 minutes, and 50 seconds. Yeah. So let's explain this one more time for the camera. All this section of code is doing, this section of generate GLSL code from C99 code, is it's taking this C99 code here, this file here, and it's converting it into a version of the file where all of the lines are wrapped into string literals. So this, and it's putting it in this output file here. So here's the input file, here's the output file. So these two variables only exist so that this line of code for awk can be one line long, and it doesn't go past the right border of my column limit. So, for example, the input line, hold on, let me fix this here. The input line of code could be some line of code, right? And then the output is going to be the same thing, except we're going to have a quote mark on the beginning, and then a new line literal, and then close quote. And so this is the format we're going to need if we're going to embed it into a shader string for an include. Okay, so now that we have that kind of commented there, we can, I don't know what we can do. We can do a lot of things. We can take a break. We can, I think it might be beneficial to explain this for the camera in like a shorter tutorial kind of thing, to put it up on YouTube. I think that searching for, can we search for, has someone done this before? Generate GLSL code from C99 code, right? So that's kind of what we're doing. How to practically ship GLSL shaders with your C++ software. How to write reusable GLSL code. So I'm sure that somebody has done this before. So let's see. GLSL minifier, pack your GLSL code into a C header. Got you. So you could minify the code and make it ugly as heck. So you're going to get rid of all this extra padding and whatnot. But if we do that, then we can't... If we try to minify it, then we can't make the... we can't make our mods folder, right? We want to actually make the code so that it can be modified. Call me stupid, but I just don't get it. Why is this conversion needed? Where are those defines used? What is this for? The only thing I think of is some demo making to place all resources in the exe file, but it's not hard to copy-paste a shader code into a C file. So, I can explain that. We want to use... guys, so they're saying specifically for demos. So demos are like these like fancy shader things that do like crazy kind of demos are just like, oh hey, so have you been to this stream before? Because if you haven't been here before, I can give you like a little explanation of what I'm up to. And okay, yeah, awesome. So let me give you a quick rundown. Awesome. So I'm working on a fractal auto tiling engine, and I'm gonna send some demo files to you. So this is my demo reel page. I'm gonna send that to you, and I'm gonna go over it with you really quick. So let's go over here really quick and show you. We're going to do the high-level overview of what I'm kind of working towards, because the code right now gets kind of intense to where, like, sometimes half the time I don't know what the heck I'm doing, and so I know people looking at the code have no clue what's going on. And so it can be kind of more exciting to know, like, what I'm working towards, and then have people kind of check back later when I have, like, more technical demos. So I made this game, like, about 8 years ago. It's like a Bomberman game, where you have these bombs that it can explode vertical, horizontal, or four ways, and when the bombs explode, they kind of destroy parts of the world, and the idea is to get to the exit door, right? So you can see that this little guy presses this little piston here. The piston causes a flame to shoot out of it. When that flame hits the bombs, it causes a chain reaction to get all those bombs underneath the floor, and the supports that were keeping that bridge together fall away, and the concrete starts to fall down. So there's certain material types, and certain material types will react differently with the explosives. So let's go look at this really quick. Also, yeah, so I'm going to try to type more in here. So let's go over here for a second. Okay, so let's take a look at this, if we can get this to work here. Yeah. I'm going to close some of these other tabs. Yeah, because I can see, thanks. Yeah. Okay, so, oh, got it. Okay, so, this demo, let me explain this to you. So I'm going to click here, and I will explain it again in the text, since I know that the connection really sucks. My connection sucks, so I will explain this again really quick. Okay, so this is GLSL-based auto tiling. Are you familiar with auto tiling by any chance? Because I can explain auto tiling a little bit more if you're not familiar with it. Otherwise, this is pretty self-explanatory to say that I'm doing auto tiles and shaders. Okay, so yeah, auto tiling is where a tile is self-aware of its neighbors. So yeah, so when I place these down, you can see that the edges, they always look nice. And I did this in shader code rather than in like 8-bit or 16-bit kind of graphics. Usually... Yeah, so I'm going to find a video for you really quick. So, let's see if I can find Auto Tiles Explained really quick. I think I can find something for you. I guess it's not that. I'm going to find it. I'm going to be able to find it really quick. Rule Tile. Let's see if I can find Rule Tile. So an Auto Tile is also known as a Rule Tile. Let's just go look at, on YouTube for a second. So I'm going to look on YouTube for you. So on YouTube, Rule Tile Explained. So it's like a rule tile or whatever. So yeah, this deal here.
You're looking for, then you can stick around.
So my bandwidth sucks, so what I'm going to do is I'm just going to give this to you. Yeah, so I'm going to give that to you, because I think since my bandwidth kind of sucks, makes more sense that you can just look at it there. Let's go look at some other stuff here. So this is just some old game I made. So this thing here is some rendering tech I made, and this is the same tile map rendered 3 different ways. So the idea here is to leverage the ability to use auto tiles and to use layers and blending to create like really interesting level designs or pieces of artwork with minimal effort. So these 3 images, this image here, and this image here, they are all the same level map, but we've just applied different rendering settings. So this rendering setting here is called Foggy Morning, this one here is called Starry Night, and this one, oh sorry, wrong. This one's Sunset, and this one's Starry Night. And right, so it's all the exact same tile map, but it just has different rendering settings applied to it. The idea is 2D graphics can still you can have any kinds of rules you want. So yeah, actually, people do make tile sets that have different styles, different kinds of rules, but the engine or some So yeah, you can have different rules. I'm most familiar with what's called Wang tiles. So if we look at Wang tiles, let's make sure that doesn't get anything inappropriate, because I don't know. So let me look at that on another browser just to make sure. Wang tile, Wikipedia. So that actually is not, this is not exactly what I was looking for. This isn't exactly what I'm looking for. So I know I said Wang tile. Now this might actually be what I'm looking for. This is a set of 11 Wang tiles. This is not exactly what I'm looking for. I'm gonna put this into my notes though, because it's kind of interesting. Wang tiles Wikipedia. So there's a graphical paper from GPU Gems that explains Wang tiles. So I'm going to see if I can find that in my notes really quick. Oh yeah, here it is. So this thing here is what I'm talking about when I talk about the auto tile rules. The specific rules that I use are for Wang tiles. So Wang tiles are a specific type of auto tile. So they're the specific way you implement auto tiles, right? Like how you ask, are there any kind of rules? And there are, and oh boy, this, yeah. So this is, that is the paper on how to do Wang style tiles. So, now I know the basics of how to do this, and it would take me a while to write like a little demo for how to do a basic auto tiling engine. I would say the easiest way, okay, so C# and C++. So if you can get graphics, if you already know how to do like tile-based graphics, then doing something in C++ with OpenGL could be an option. If you want to use C#, you could use like the simplest way might be like you could probably use, if you want to do something simple to get this started, to just get something working, right? Because if you're new to this kind of stuff, I started. Or, yeah. So, I can explain more of it to you for a second. So why don't I, since you're here, since I have your attention, why don't I explain some of the basics to you? So, I do like to draw like little diagrams to explain. So, let's say you have a tile, and this tile, I've used C++ and OpenGL before. Oh, awesome. Awesome. Yeah, okay, so here, I'm going to show you here. So let's say we have some tiles, and I want to pay attention to this tile in the middle here. And this tile here can be one of 16 graphics, right? So we don't know what graphic it's going to be. Okay, so let's make a strip, like a bitmap strip of graphics here. Let's make 16 of them. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, SFML, yeah, that would be a good way. So I did a lot of my first projects in SFML. So let me take a quick go over here really quick. So this little tile-based editor thing I did this with SFML, but then I did it using SFML with Golang. So it just makes it a lot simpler if you're just trying to deal with pixels. Oh yeah, no problem. See you around. And thank you if you subscribe, because I see my subscription count went up by 1. But good luck in class. And I can explain more of this to you later if you just ask about it. I'll give you the little rundown and tutorial of how this kind of stuff works. Because I do know a pretty good amount of it, because I do a lot of it. But I will see you around. I'm just going to get back to coding my usual stuff that's really complicated, but I'll leave this kind of tutorial for you later. And I'll just make a note of your name, and I'll just keep this file here in my, I have a folder in my documentation called fan for fan service, and I'm just gonna, I'll put your name here in this file so that next time you show up, I can be like, oh, what was I showing you, right? So I'll just make this file right here with your name, and then next time you show up, I will be able to pull that up for you. So, but yeah, good luck in class. Okay, so let's paste this. Alright, so let's take this and say okay, and let's edit this file, and then let's take that rule tile thing I was looking at. And that was this thing here, take that. Okay. And now I can put this over here. Okay, and I can close this. And this was the build script I was working on, and I think I was gonna do like a little tutorial. I think I want to do a little tutorial on how to procedurally generate GLSL code, right? Because I was kind of looking at that kind of stuff. So let's go back to what we were doing earlier and just see, like, how do we procedurally generate GLSL code. So let's kind of generate GLSL code from C99 code, right? So that's kind of the idea of what we're looking at. And C++ templating, whatever. I think I might actually have an interesting kind of workflow here that nobody else has used before, or something that's not used very often. Yeah, so this is how you kind of embed something into a shader. How to practically ship GLSL shaders with your C++ software. The problem is this is hard to edit and maintain debug. Yeah, that is true. There is just store them directly in the executable, store them in a separate files with nothing in between. If you want self-contained, putting them into binary is a good idea. Okay. C++11. Okay. Okay. Oh yeah, so this is actually a pretty good suggestion. Okay, so I think I'm actually going to answer this because I am armed with everything that's needed to answer this. So, So, now, should we start, so if we do this, we really should start a new video for this. where we can kind of explain what we're up to here. But I think that we can definitely answer this question on Stack Overflow for some more credibility, and explain our build process a little bit in another video, so we can kind of upload this to YouTube and get some credibility here. So what we're going to do here is we're going to explain the process of how we do what we do, right? So we're going to explain how we convert C99 code to GLSL code, right? Can we even get to our old blog? We had an old blog. I wonder if I can even get that. www.blog. I wonder if I can log back into my old blog spot, because that'd be pretty cool if I could. I'm gonna try to log into my old blog spot really quick. Probably not. Probably lost that. Sign out. Oh, wow. Not this bullshit. So yeah, the reason I don't have my old blog anymore is because, Blogspot thinks it's cool to link it to blog site not linked to Gmail. So I do not want to use a blog that is linked to Gmail, because it's very annoying when I am trying to yeah, okay, you know what? We're just not going to do a blog. That's just going to get distracting. Okay, so we're going to take a break. I'm going to take a break and do a new stream later. I think that right now I just want to... I'm going to do another stream where I'm going to explain how the build system for the current project works. So before we do that though, let's make sure everything's in good working order here. So first thing is, double click this, make sure everything builds, make sure it runs, and then we will we'll stop the stream, right? Okay, so that runs. Let's do a git bash here. So git bash here and do git status. Okay. Alright, so I'm going to get out of here. So let's look at the title screen here. So, we just did Polyogl, which was the polyfill namespace for our OpenGL functions. And the idea of that was we just did this like refactoring where we're kind of reorganizing things and getting rid of some of the nested project structures that we had. And we're done with that. We did all that and we're good. And now we need to do some more push-ups and things, because if we look at our push-ups, it is a new day, it is Friday. So we need to do our push-ups. We don't need to do all 100 right now, but we need to get to a 110 for the day. So let's take a break, do some push-ups. Technically, if we wanted to do 20 per hour, we already owe ourselves like 80 push-ups already. But let's just try to do at least, I don't know, 30 or something. Anything is better than nothing. And then we'll be back to describe how we do C99 to GLSL code conversion.